Now, let's look at this. Okay, suppose we had, again, evaluated, simplify without using the calculator. Suppose we had the log of 10,000. Log of 10,000. All right, so how would you do that? The base is 10. It's equal to 3. It's equal to 3. So you say equal box, then change to the exponential. If there's no base there, it's a common logarithm. That means base 10. So 10 to the box equals 10,000. 10 to what power is 10,000? Not 3. The fourth, right? 10 to the third power is 1,000. 10 to the fourth power is 10,000. So the answer is 4. Number 2. Suppose you had, let's see. All right, suppose you had the log of 10 to the 7th power. What do you think that's equal to? All that's very similar to what you did a while ago. When you have 10 to the raised to the power, yeah, that's all you do. All right. So, no, it's not 1. What do you think this is equal to? Y'all are, okay, now remember, you've got to write an exponential. So draw the box. If you can't look at it and determine the answer, draw the box. You can draw whatever you want to. You can draw whatever you want to, girl. So now change it to exponential. What's the base? 10. Now remember, that's a common logarithm, right? Common logarithm has what base? So you say 10 to the box equal the argument. What's the argument? 10 to the 7. Now the base is the same. What must be the exponents? So that's 7. 3. What now?
No, it's the argument.
All right. Log, 10 raised to the log of 72. What's that equal to? Yeah, we just talked about it previously. Whenever the log is in the exponent and this base are the same, it's just a what? The argument. So 72. Because that's 10 and that's 10, right? Okay. 4. All right. Now remember, a natural logarithm has what base? E. And what's the symbol for a natural logarithm on your calculator? ln. Okay. So look at this one. The ln of E. ln of E. What do you think that's equal to? Yeah, it's lowercase. So ln E, what do you think that's equal to? Nope. It's 1. So you say equal box. Now what I would do is if you see how most of you didn't know what to do at first, I would rewrite ln as log. Log with what base? E. And again, what's the argument though? No, what's the argument? What's the argument? E. This is your argument, guys. That's your argument. Ln is log with what base? E. So we just talked about this. Log base E is ln. Okay, so that is the same thing. So ln is log base E. So now say equal box, and now you can tell me the answer. What's the base here? E. E to the box equal the argument. What's the argument? So the base is the same, then these have to be the same. What's this right here? 1. So you got to remember, ln is log with base e. That's your natural. I'm sorry. Yeah, that's your natural logarithm. Base e. Okay. Now what about this one? Natural log of e to the 8th power. Huh? Okay. If you want to write it, you say log. What's the base? What's the argument? Nope. Argument's not 8. Argument's not 1. The argument is this. That goes here. All I'm doing is rewriting ln with the letters log. And ln is log what base? E. I asked you what the argument was. What was I taking the natural log of? E to the 8. E to the 8 is your argument. So I'm going to ask you again. What is the argument? E to the 8. What goes here? E to the 8. Okay. Box. What's the answer? So e to the box equal e to the 8th. So what's the answer? 8. The answer is 8. Okay, 6. 6, you have... All right, let's suppose you had this. E to the natural log of 4x. What do you think that's equal to? 4x. Because this ln is log base e, right? So that base and that base are the same. It's just the argument. So what's the answer? 4x. What do you think that's equal to? 8x. Because even if you didn't know that, you would say ln is log what base? What's the argument? Nope. E to the 8x. This is your argument. Circle it if you need to. That's the argument. So that goes here. So equal box or circle, whatever you want to. So e to the box equal the argument. What's the argument? So therefore these have to equal, right? So that equals 8x. All right, 8. All right, so let's look at this. The natural log of 1 over e to the 5th power. Think about what we did a while ago. -5 is the answer. She just needed a couple of reviews and that was it. She's got it. How I wrote what? ln of 1 over e to the 5th power. The natural log of 1 over e to the 5th power. So remember 1 over e to the 5th is e to -5, right? And so I'm going to write this as log base e of e to the -5. You agree that 1 over e to the 5th is e to -5? And you agree that ln is log base e? So I'm going to say equal some exponent box. So your base is e, so you say e to the box equal the argument. What's the argument now? Nope, the argument is not -5. What's the argument? E to -5. So box must equal -5. All right. So just like you did a while ago with one of the other ones we did. So you need to bring that e to the 5th to the numerator. All right, and then one more with this, and that should take, well, that should take care of part of it. Let's suppose you had 10 raised to the log of the 7th root of x. 10 raised to the log of the 7th root of x. What do you think that's equal to? Huh? It can't be e because that's not a natural logarithm. That's a common logarithm. So there's no e involved here. Who said 1/7? 1/7 is the answer. Because you have to rewrite, remember the 7th root of x is x to what power? x to the 1/7. And so this becomes 10 log base 10, right? Of x to the 1/7. Oh, it's not just 1/7, it's what? Remember, when the base and they're the same, then it's just what? X to the 1/7. Remember, the base is the same? So it's x to the 1/7. Or you could have said this. Watch. So it's equal, let's put here, equal x to the 1/7. Or you could have said the 7th root of x. Doesn't matter. So remember a while ago we did this, right? In the previous we said this. 7 log 7 base x equal to what? When the base is the same, what's this equal to? What's it equal to? It's just the argument, right? What's the argument here? X. So if I have 8 log base 8 of x squared, what's the argument? X squared. So if I have 10 log of 7 root of x, what's the argument? 7 root of x. Or you could have written it as x to the what power? 1/7. Okay? All right. Okay, so that takes care of part of part 2. Now here's the other part of part 2, the first 2 questions. Okay, so on your calculator, remember your calculator only uses 2 bases for logarithms. Base 10 and base what? E. Base 10 is common logarithm. Base E is called what? Natural logarithm. All right, so if you look at ln, the n here would stand for natural, and then the L logarithm. So ln. Yeah. Okay, so on your calculator, go ahead and determine what the log of 10 is on your calculator. Now, you know the answer. What's the answer? Real quick. Oh, no. 1's the answer. 1. 10 to what power is 10? 1. On your calculator, you got 1? You got 1. On your calculator, when you take the log, log of 10, you get 1. It kind of makes sense because 10 to the first power is 10. Your base is 10. 10 to the first is 10. What's the log of 7.2 approximately equal to? 7.2. Now you can't do that without a calculator. So 7.2, just like to the nearest hundredth, 0.86. Log of 1 without the calculator, what's that? Log of 1. Without the calculator, what's the log of 1, do you think? 0. 10 to what power is 1? 0. On your calculator, do you get 0? Log of 1 is 0. All right. 4. What do you think, without using a calculator, what do you think is the log of negative 2? No, without using a calculator. 1/2? And without using a calculator. So if you use a calculator, don't say anything. Okay, so let's think about that. Let's put box, right? What's the base? What's the base? 10. So 10 to the box is negative 2. 10 to what power is a negative 2, do you think? I'll make it easier for you. Suppose this was log, hold on. Suppose this was log of negative 10. What do you think that's equal to? 10 to what power is negative 10? What do you think? What do you think? Negative 1? 10 to negative 1 is 1/10. Is 1/10 the same as negative 10? Yeah. The base is positive, right? A positive number raised to any power is always what? Positive. It is never what? Negative. This is not possible. You can't take the log of a negative number. Okay? You cannot take the log of a negative number. So the argument, so the same thing here. You can't take the log of a negative number. It's not a real number. So this is undefined. That's undefined. So that's going to be important when you start graphing logarithms, because the domain is not all real numbers. Hence why I told you to put this in your calculator or to think about it. What was that? What? I know, I did. You're right. You're right. Okay, but the idea is that you can't take the log of just any number. And that's going to be important when you start graphing logarithms, because the domain is not all real numbers. You can only take the log of a positive number. You can't even take the log of 0. Watch, don't use a calculator. Think about this. Log of 0. So if you think about it, 10 to the box equals 0. 10 to what power is 0? There isn't any. 10 to no power is 0. 10 to a power is always what kind of number? Positive. A positive number. Okay, so that's not possible either. Okay, so I can only take the log of a positive number. So if I have f of x equal log of x with some base, it doesn't matter what the base is. I don't care what the base is as long as it's positive and not equal to what? No, 1. Because remember, 1's a positive number, so you have to say as long as it's positive and not 1, because it can never be 1. 1's a positive number. So here, you would have to also know that I can only take the log of a positive number. So x must be what kind of number? Positive. So x must be bigger than 0. So when you, in the first two problems, you're asked to find the domain of this log function. So f of x equals log base 6 of x minus 3. Log base 6 of x minus 3. And so you want to find what's the domain. What can I plug in for x and I'll get a value for y? That's the question. Well, my argument, what's the argument here? X minus 3. X minus 3 must be what kind of number? Positive. So you're going to set up an inequality. You're going to say x minus 3 must be bigger than 0. And you solve for x and you found your domain. So what's my domain? Any number that's bigger than what? No, 3. A number bigger than 3 is your domain for this function. So as an interval notation, what's the answer? Parentheses, 3 to what? Infinity. All right? So that's your domain. So x is greater than 3. As an inequality, if they ask you for an interval, you'll say this. All right, and then f of x equal log base 4 of x plus 9. It does not matter what the base is. To determine the domain, all you're looking at is the argument. Does not matter what the base is. Does not matter. You got to look at the argument. So x plus 9 must be what kind of number? Positive. So you solve this inequality. So x is greater than what? Negative 9. So that's your domain. As interval notation, what's the answer? In parentheses, infinity. All right, so that takes care of that worksheet. Okay, now. Okay, so this is section 4.3. So we're still talking about logarithms, except this time we're talking about properties of logarithms. Properties. Properties of logarithm. That's now all I gave you so far was parts 1 and 2. Now on your final, there are going to be some other parts to 4.3. But on test 4, it's just part 1 and part 2. Test 3, part 1 and part 1 and part 2. Now on your final covers a little bit more of logarithms. All right, so let's talk about properties of logarithms. Okay, so you remember last semester when we talked about the product rule. And so the product rule, you had something like this. You had b to the x times b to the y, something like that. And I'll go ahead and use the letters m and n because that's what the property of the logarithm is going to use. So let's change this to b to the m times b to the n. So remember last semester and even the semester before that, when you multiply like bases, what do you do with those exponents? You add them. So that's b to the m plus n. Okay? Now remember, a log is nothing more than an exponent, correct? Okay, now notice this exponent, when you multiplied like base, you did what to those exponents? You added them. So now let's look at this in terms of logarithms. So if I have the log of a product, regardless of the base b, doesn't matter what the base is, I can expand this log of a product. So the product rule says I do what to those exponents? Add them. Remember, log is an exponent. So I can rewrite this with what operation? Addition. So this becomes the log of m plus the log of n. The log of m plus the log of n. Now make sure you write your base. What's the base here? B. B. All right, so that's the product rule for logarithms. So the log of a product, you're going to write as an addition problem. And it kind of makes sense if you think about it from last semester. Product rule says you do what to those exponents? Add them. I'm taking the log of a product. I got to change to what kind of problem? Addition. Okay? Now remember the quotient rule. The quotient rule was this, b to the m divided by b to the n. What did the quotient rule say? You divide like bases, you subtract exponents. That's correct. So that's b to the numerator, exponent of the numerator minus the exponent of the denominator. Okay, so when I look at this in terms of a logarithm, the log of m divided by n this time. See, this was a product. Product became a what? Addition. Quotient becomes a what? Subtraction. Okay, let's put the base b here. So that's going to be the log of m minus the log of n with the base, and the base is b. Okay, and then one more property, and then we'll look at some problems. So that's the product rule. That's the quotient rule. Product from last semester, you multiply like bases, add exponents. So hence, log of a product becomes an addition problem. Quotient, divide like bases, subtract exponents. Hence, the log of a quotient is a subtraction. You also learned about the power rule. Power rule. So the power rule last semester, or the semester before that, was this. If I have b to the m raised to the n power, b to the m raised to the n power, what did y'all do? What was that equal to? Do you remember? You multiply the exponents. So it's b to the what? N. So the power rule says I multiply the exponents, right? Okay, so here's how it's going to look in terms of a logarithm. You're going to have the log base b of m to the n power. Log base b of m to the n. Okay? So remember the power rule says I do what to those exponents? All right. The log itself is an exponent, right? But that exponent is also being raised to an exponent. Remember, exponent to exponent, you do what to them? Multiply. M times n. This log is an exponent. It is itself being raised to an exponent. So basically, I'm going to take the exponent n, and I'm going to multiply it by this other exponent. So n times the log of m. So basically, you'll take that outer exponent, you're going to bring out in front and write it as what kind of problem? A multiplication. All right. So you're going to take the exponent, and you're going to say that exponent times this. Okay? All right, so let's look at some problems dealing with those three properties. Okay, the first one. So the directions are going to say use the properties of logarithms to expand. So use properties of logarithms to expand each logarithmic expression. Okay, now it's also going to say this. Simplify where possible. Simplify if you can. Simplify without using a calculator. So remember, we spent quite a bit of time doing stuff without using a calculator. So that's going to be important here. That's why we did that, because you're going to need to be able to do it here. All right, so see the part on the worksheet where it says where possible, it should say simplified log right here. Where possible, simplify. I have calculator logarithmic. It should be simplified. Simplify logarithmic expressions without using a calculator. Okay? Did I have the other one? I have the word evaluate. Evaluate means the same thing as simplify. But this is when you got to fix. This should say either simplify, evaluate. Okay. So it's very simple. As long as you remember these properties, you're done. Now that's for the first two. Now part three is we're going to go backwards. So you got to be able to do these two first before you can go backwards. All right, number one, you have the log base 4 of 3 times 4. Oops, that's too similar to what we just have in the worksheet. Log base 8 of 2 times 7. Okay, that's a simple one. So I'm taking the log of a what? No. Don't say 14. Leave it as 2 times 7. Yeah, product. I'm taking the log of a product. That's how you're supposed to think about this. You're supposed to think about it like that. Don't do 14 because then you can't do anything else to it. The direction says use properties of logarithms to do what? Expand. So I want to rewrite that product as an addition problem. So if you write it as 14, what are you going to do? Okay, you're saying it incorrectly though. It's log base 8. You got to use the word base. So it's a log base 8 of what? 2 plus a log base 8 of 7. That's the answer. Number 2. Log base 7 of 7x. What property am I using? Am I using a product, quotient, or power? Product. So what does that equal to? Of 7 plus log base 7 of x. All right, that's where I'm at. Now, at each part, you're supposed to ask yourself, can I simplify this without using a calculator? This I'm pointing to right here. No. Can I do this one? No. There's no way you can tell me 2 to what power 7. Can I do this one, though, without using a calculator? Yes, you can. That's 1. So the answer is what? 1 plus log base 7 of x. That's the answer. So make sure you don't leave it as log base 7 of 7, because it says simplify whenever possible without using a calculator. So we spent quite a bit of time doing something like this. Okay, so log base 7 of 7 is 1. 7 to what power is 7? 7 to the first power is 7. Number 3. Log of 100,000 x. What property am I using? What property? Product, quotient, or power? Product. You're multiplying, right? It's a product. That's not a division problem. So it's a log of 100,000 plus a log of x. So that's where I'm at. Can I simplify any of these without using a calculator? Yes. What's the log of 100,000? No,
No.
10 to the 10. If you say 10 to the 10th power, that's 10 zeros. 10 to what power is 100,000? 5. There are 5 zeros, right? That's 5. So the answer is 5 plus the log of x. 4. Log base 6 of 4 divided by 11. Quotient this time. So how do you write it though? Say the correct words. You can say log base 6 of 4 minus log base 6 of 11. Can I simplify anything? No. Now, if I knew how to use a calculator with these, yes, I could approximate, but we're not at that point. 5. Log base 6 of 36x. Log base 6 of 36x. Product rule. So how do I write it? Can I simplify any of those? Yes, you can. Which one? This one right here. What's that equal to? 2. Because 6 to the second power is what? 36. Y'all see that, right? Log base 6 of 36 equals box. So 6 to the second power is what? 36. So the answer is 2 plus log of x base 6. All right, number 6. Okay. Log base 3 of y divided by 81. Log base 3 of y divided by 81. All right, so what rule? So log base 3 of y minus log base 3 of 81. So obviously I can't simplify this because it has a variable in it. But let's look at this one. 3 to what power is 81? 4. 3 to the 4th is 81. Log base 3 of 81. So 3 to what power is 81? 4. Because 3 times 3 times 3 times 3, that's 9 times 9, right? Which is 81. So the answer will be log base 3 of y minus 4. Good. Just using the properties and using what we did in the last 2 worksheets. The natural log of 3e. Now remember, natural log has what base? E. Remember, natural log has base e, so that's a natural logarithm. Common logarithm has what base? 10. Okay, so write it out. What rule? Product. So what are you going to write it as? Natural log. Say natural log. Natural log of 3 plus. Can I simplify any of these? Yes. Which one? Natural log of v. What's the natural log of v? 1. Very good. Natural log of 3 plus 1. Natural log of v is 1. If you don't, hopefully at this point you can quickly see this, but if you can't, use your not use your calculator. It did not mean that. Write it out. Ln means log what base? E. And what's the argument? E, right? Argument's E. Argument's this. So equal box, you say the base, which is E, to the box, equal the argument, which is E. So the base is the same, so these exponents have to be the same. So that's just 1. 8. natural log of e divided by z. That's a z right here. Z. So what are you going to use? But what rule? Quotient. Natural log of e minus natural log of z. Can I simplify anything? This is just 1, right? 1 minus natural log of z.
Is it okay if we write 1 minus like
No, leave it as ln. No, don't. You'll never see it written as log base e. You need to use the proper notation. Proper notation is ln. Okay. All right. 9 log of x to the 8th power. What property are you going to use here? Power. So what does that say I do to this 8? Pull it out in front, right? So you're saying this. You're saying I'm going to take this power. I'm going to write it out in front as a product. Remember, the power rule. Power raised to power. You do what to those two things? Multiply. So there's going to be 8 times what? Log of x. So that's your answer. 8 times log of x. Okay. 10. The natural log of, let's say, 7 to the x. What do you think that's equal to? What property are you going to use here? The power. So what's the answer? No, not 7x. X log of x natural log of 7, right? Okay. X natural log of 7. You take that power, go out in front, write as a product. Okay, so that takes care of that worksheet. Okay. Now, so remember the properties, right? We only had how many properties here? 3. That's all we had. So let's look at worksheet 2. So if you can do this one, you should be able to do the next one. It's very simple. Same directions. So the directions are use properties of logarithms to expand. Use properties of logarithms to expand. And then remember, simplify if you can. Okay? All right, number 1. Log base b of x to the 8th power, y. All right, now be a little bit careful. So now we're looking at a mixture of stuff. So remember a while ago, you only used either the product rule or you used either the quotient rule or you used either the power rule, right? So what's going to happen here, you're going to use several of those properties in one problem. You're going to use a power at some point because you see that 8, so that's going to be a power. What else are you going to use? Product. So very good. You're going to use 2 properties. You're going to use the power rule at some point and the product rule. Now the question is, what do you use first? It matters. No. Okay, now listen. In order to pull this thing out, the power out in front, the whole argument has to be raised to that power. What's the argument of log? This whole thing. Is this whole thing raised to the 8th power? No. Just at x. So don't pull the 8 out in front. That's incorrect. Now we're going to do one in a little while where that's the situation. But in order to pull that power out in front, the whole thing has to be raised to the 8th power. And it's not. So what you got to do first is do the product rule first. So the product rule says what? Log base b of x to the 8th plus log base b of y. Now I'm going to ask you, can I use any other properties? Yes, now I can use what? Now I can use the power rule with this one because what's the base here? What's the argument here? X to the 8th. See, the argument here was x squared y, right? Here it's just x to the 8th, so all I have is something raised to the 8th power. Now I can pull that 8 out in front. Yeah. And that's it. So notice how you struggled at the beginning. Some of you wanted to do the power first, and you couldn't because the power rule says this whole argument has to be raised to that power, and it's not because y is not being raised to the 8th power. So you have to do the product rule first, and then do the power. Okay. All right. Number 2. Log base 6 of x to the 5th power divided by y to the 4th power. Power and quotient. Do I do the power first? No, you do the quotient first. Because I can't do the power first because this whole argument is not being raised to a power. I mean, it is being raised to the first power, but it's not all being raised to the 5th, and it's not all being raised to the what? The 4th. Okay? So you can do what first? Quotient. All right, so what do I write? X to the 5th minus y to the 4th. Now what can I do? Now what property can I use? Power. So circle this, and it tells you to pull this out in front, right? So what's the answer? 5 base 6 of x, that's a 5, minus 4 log base 6. I can't even tell whether mine's a 6 or a b. That's a 6 of y, right? Here's your answer. Right, just learning some properties right now. Okay, next one. Log base 3 of 9x to the 5th power. Log base 3 of 9x to the 5th power. First a product, very good. So that's going to be log base 3 of 9 plus log base 3 of x to the 5th, right? Okay, now remember, you want to try and get all of your points. So if this is worth 6 points, this will probably give you 2 of them out of the 6. So you got 2 out of the 6. Try and get 4 more. Okay, so you can do the power here. I agree. So you do that, you'll get another 2. Huh? Simplify this. What is that equal to? 2. 2 plus 5 log base 3 of x. So that gives you your 6 points. Right. So you got to remember, log base 3 of 9 is 2. Number 4. You got to practice with this before you can really grasp how to use these properties. Okay, so look at this. So suppose we had the log base 5 of 25 x to the 3/4 power. Let's make it like 125. Put 125. So log base 5 of 125 x to the 3/4. First product. So I say log base 5 of plus log base 5 of x to the 3/4. Okay. All right. I'll give you 2 points. Is 3. Very good. 5 to the 3rd is 125. Very good. So that gives you 2 more points. No. 3/4, right? 3/4 log base 5 of x. Yep. Just using those properties. So when we solve equations coming up, these properties are going to be important. All right, 5. Suppose we had log base 7 of the cube root of x divided by 49. So write this down. Log base 7. Yeah, that's a cube root of x in the numerator and then 49 in the denominator. What do you have to use first? Quotient. So 2 points you're going to get log base 7 of cube root of x, right? Okay. Minus log base 7 of 49. Okay. So try and get as many points as possible. Huh? You can change both of them. You got to remember about this right here. So cube root of x is equal to what? X to the 1/3, right? Cube root of x is x to the 1/3, right? Okay. So what I'm going to do is I'm going to rewrite that cube root of x. I'm going to write that cube root of x as x to the 1/3, and here's why you need to do that. Because then you will see that I'm going to use what property here? The power here. So now if I use the power right here, what does that give me right here? 1/3 log base 7 of x. And what does that equal right here? 2. Okay, so you got to remember these radicals, how to write them as rational exponents. Okay, number 8. Okay, and number 7. Sorry, number 6. Number 6. Okay, listen carefully to this one. Log base b of x to the 5th, y to the 6th, divided by z to the 4th. Product rule, quotient rule, what else? Power, right? So it's all of them. All right, just go take some Advil. Take some Advil. Oh, I saw you, girl. You took like a whole bottle of them. No, when you do the product first, do the quotient first. You gotta do the quotient first. That's z to the 4th. Yeah, you gotta do the quotient first. So the quotient is gonna override the product. So you do the quotient first. So basically you're gonna have this. Log base b of x to the 5th, y to the 6th, right? Minus log base b of z to the 4th. All right, so if this is worth 8 points, you got 2. Now, I'm going to cover this part. Tell me about this. What does that look like? Product. That's product. So rewrite this as a product now. So this right here is log base b of x to the 5th plus log base b of y to the 6th minus log base b of z to the 4th. All right, so you got 4 points. Okay, so notice I had to do the quotient rule first, so that's your subtraction. So the log of the numerator minus the log of the denominator, right? Then the numerator, though, that was a product, and I'm going to use the product rule, so that becomes an addition problem. Now all I got to do is we use what property next? Power. So it's the answer. Of x plus 6 log b of y minus 4 log b of z. All right? You'll be fine. You'll be fine. 7. All right, now look at this one. Log of 3 divided by 4x. Log of 3 divided by 4x. Quotient first. Are there really any powers? No powers, but quotient and what? And product. Very good. Quotient and product only. Which one are you gonna do first? Quotient. Okay, quotient. Log of 3 minus log of 4x. Okay, now, if you're not careful, this is where you see most of you probably, or all of you probably could have gotten this very easily. If you're not careful, you're probably going to lose 1 or 2 points here. You want to get as many points as possible. You want to get all of them, though. All right, so you see this right here. You got to be careful here, okay, because you're subtracting all of this, right? So think about when we solved those rational equations and we put parentheses. Remember we subtracted and we put parentheses around stuff? So here you're going to do this. You're going to say log of 3 subtract. Now I'm going to change this to what kind of problem? Product. So what kind of operation? Addition. Put that in parentheses like this. So put that in or brackets. Put that in parentheses or brackets. So that's the log of 4 plus the log of what? X. You see, if you did this, I'm going to show you. What some of you would do is this. You're going to say log of 3 minus the log of 4 plus the log of x. That's what you would have probably said. That's not correct. Because you are subtracting all of this, right? So not only am I subtracting the log of 4, but I'm also subtracting the what? Log of x. And you're not doing that. You're adding the log of x. So that's why you need to put that in brackets or parentheses. Now distribute. No, you didn't. No, you did it here because you're subtracting. And so you got to be careful because now you got to distribute this. So what's the final answer? Log of 3 minus log of 4 minus log of x. So remember, this is not correct, right? This is where the issue is, right here. All right, so be careful there. This is where some of you are going to mess up if you're not careful with that. So whenever you're subtracting the log of a product, make sure you remember you're subtracting both of those terms, log of 4 and the log of x. So both of those should be subtractions right here. Okay? So you got to be careful with that one. That's what's going to get some of you. That should be the only one that should be the difficult one. Number 8, suppose you had the log of 5x to the 6th power. What do you think? Product and power. What do you think I'll do first? Power. So remember, we had that issue earlier where I can find it. Yeah, so remember earlier we had something like this. I want you to compare these two. Suppose I had 5 to the 6th. Let's do this. Suppose I had log of 5x to the 6th. You do product and power, right? But which one should you do first? Product. Because you can't do power because this whole thing's not being raised to the 6th power. Okay? So here you would say the log of 5 plus the log of x to the 6th. And then you do the product rule here. I'm sorry, the power rule. So there's a log of 5 plus 6 log of x. Here, though, this is all being raised to what power? The 6. So I can do what first? The power first. I can do the power first. So compare those two. See how they're different. So this becomes 6 log of 5x. Now what do? Okay, good. So you got to say 6 for both, right? Just like when we did the subtraction right here. You're subtracting both of those. So you're subtracting log 4 and you're subtracting what? Log x. So here you are multiplying 6 by the log of 5 and you're multiplying 6 by the log of x. So if you want to put the brackets like we did earlier, here's what I would do. Just make sure you see this. So this is 6 times, I'm going to write this as log 5x. I'll agree that that's the same as this? Okay, now do the power rule, the product rule with this in the bracket. So that's 6 times what? Log 5 plus what? X. Now do what? Distribute. So what's the answer? And that's it. No, you don't. No. Yeah. Yeah, so, no, you don't have to do all those steps. You probably have to do this one, and then you can go from here to the answer. Yeah. Yes. No, they want you to expand it, so they do want you to distribute. So the answer has to be what I have boxed off. Okay? It has to be this. So this has to be the answer. Make sure you see this. 9 natural log of 4e to the 5th power. It's not that bad. Just practice with this. What are you going to use first? Power. Good. So that's 5 times what? 4e. Okay. Now kind of think about what we just did. So if you need to write in those steps, you can. But if you don't want to, what would be, not the final answer, but maybe the one before it, what would you write it as? 5 natural log of 4, good, plus 5. Very good. Y'all agree? All right. Y'all see this, right? Okay. Now, can I simplify something? The natural log of e. What's the natural log of e? 1. Very good. So y'all agree that this right here is what? 1. And 1 times 5 is 5. That's it. It's not that bad. You got it. Okay? You'll see what it looks like? All right. Now, you know, in a test, you're going to be stressed out because of the time, so you may forget this, but at least you can get most of your points. Wow. That's just human nature, guys. I mean, you know, you're stressed out. Everybody does it. I do it. I'm just talking about. I'm just talking about in terms of even your job. You know, you stressed out and you forget something, or you mess up on something. But you know, it's not the end of the world. Life goes on. All right. See it? But at least you got most of it, if not all of it. All right, 10. Let's do this. Natural log of e divided by y to the 5th power. Oops, let's do 6. What do I do first? Power first. Do the power first. So that's 6 times the natural log of what? Divided by y. Y'all agree? Now, do what? So what would that be? Okay. Very good. There you go. One more time and you're done. That girl's going to get 100 on the next test. 6 times 1. Very good. The natural log of e is 1. There you go. So all that struggle you did at the beginning of class is paying off now. 6 what? So natural log of y, right? And that's it. It's a long weekend y'all have. Just go and enjoy your weekend. But you can see the light at the end of the tunnel now. It's almost over. And then you'll get an A or B in here and you'll be happy. All right. Okay. Well, to be honest with you, you're not going to see videos in your next class.